Hi everyone, welcome back. Today we are going to see about the application of diode. That is nothing but an rectifier. So in diode application is nothing but rectifier. The rectifier which is used to convert an alternating current into direct current. So there are several types of rectifiers. Broadly it can be classified into two types. One is nothing but off wave rectifier, another one is full wave rectifier. Again, further the full wave rectifier is classified into two categories. One is center tapped full wave rectifier, another one is center bridge rectifier, full wave bridge rectifier. So the first one, off wave rectifier. So in a off wave rectifier, there will be a supply voltage. Here we are supplying the voltage of 230 voltage. So the 230 voltage which is given into the single phase transformer. So the single phase transformer, it convert the high voltage AC into low voltage AC. For example, the 230 voltage AC is converted into 12 volt AC or 10 volt AC or 24 volt AC. So it is based on the number of turns in the secondary of transformer. So the main purpose of using this step down transformer to convert the high voltage AC into low voltage AC. Then the low voltage AC which is given into the diode. So here, so the secondary, the upper part is nothing but upper part terminal is denoted as A and denominator is denoted as B, the terminal. Okay, so here there will be an diode and there will be an load resistance are connected in the secondary of a step down transformer. So here in the right hand side there will be an supply voltage. That is nothing but in pure sinusoidal waveform. So the sinusoidal waveform is nothing but a supply voltage to the diode. So the supply voltage, it consists of positive off cycle as well as negative off cycle. So positive, negative, it will be like that, it will be continued. So during the positive off cycle from 0 to pi, so the current direction will be upwards positive and downwards is negative. So the current is always flow from positive to negative. So it start with the positive, that is nothing but terminal A, from terminal A to diode to load, and load again it will be connected with terminal B, that is nothing but negative. So at this case, the current will flow from anode to cathode in the diode. So the current will be conductor. So we can get the positive off cycle output from 0 to pi and 2 pi to 3 pi, so like that. Okay. But during the reverse bias condition from pi to 2 pi, so the polarities gets changed. The upwards is minus and downwards is positive. So the current is always starts flowing from plus to minus and start with the plus to load to diode. So here the current direction is opposite to the diode. So from anode to cathode. So the diode will not conduct. So we can't get the output in the reverse bias. So only we are getting the output in the forward bias. So this is the full wave rectifier with respect to center tapping positions. So here the same high voltage AC is converted into low voltage AC. That will be given into diode. Here we are using the two diodes for the full wave rectifier. So during the positive off cycle, the current direction start with A to diode D1 to RL is connected with O. So during this condition, the diode D1 is conducting, so we can get the output in the positive off cycle. At same time, the terminal B is connected and we can start with O to RL to diode D2. But in the reverse bias, so diode D2 will not conduct. Okay, so during the positive off cycle, D1 alone conduct. And during the reverse bias condition, the current direction will start with the plus to D2 to RL to O. So during the negative off cycle, diode D2 alone conducting. So we can get the negative off cycle output. So while combining the both positive off cycle as well as negative off cycle, we can get the continuous and constant output voltage. And here the full wave bridge rectifier. So instead of 2 diode, here we are using the 4 diodes. So the supply voltage, output voltage, everything is same. Why we have to use this full wave rectifier, full wave bridge rectifier? That is because of only one reason. That is nothing but peak inverse voltage. So in center tapped, the peak inverse voltage is 2 times of supply voltage, but here an peak inverse voltage which is equal to supply voltage. Here during the positive half cycle, it start with the plus to D1 to load resistor, and again it start like that. So it can flow. So during the positive half cycle, diode D1 and D2 will be conducting, and during the negative half cycle, diode D3 and D4 will be conducting. So for a single half cycle, there are 2 diodes will be conducting. So the peak inverse voltage can be slightly decreases. Off will be reduced. Okay. And this is the comparison with respect to number of diode and the transformer which is recovered and maximum efficiency, so like that. And this is the assessment for full wave rectifier. The minimum number of diode which is recovered either 2, 1, 4 or 3. So put your answer in the comment section, and these are the few references. Thank you.